Hey everyone, welcome back. I am Neeraj. In this session, we will see how to do object-oriented programming in Go. As we all know, Go is not an object-oriented programming like C++ and Java. But yes, we can achieve object-oriented programming in Go using plain struct and interfaces and packages. That we will see in this session, no worries. Before going forward, first let's try to recap about object-oriented concept. There are several features, but the core features of the object-oriented programming is inheritance, encapsulation, and polymorphism. These are also referred to as the object-oriented paradigm. So these are, we can think of it as a building block of object-oriented programming. So inheritance is a very important concept that adds the capability of code reusability. We define the core attributes and the methods in the parent class, and all the derived classes or child classes, they inherit the properties defined in the parent class. So this way, so we define the core features at one single parent class. Likewise, encapsulation, in simple terms, the meaning of encapsulation is the data hiding. So using encapsulation, we hide data from outside the world, and only the class members can access those sensitive data, right? And next we have polymorphism. The word polymorphism, very simply, it refers to having many forms, and polymorphism adds the capability to take more than one form. If you're coming from Java background or C++, so you might have gone through all the things like how we can apply those things. Like we have classes, objects, and access modifiers, public, protected, private, interfaces. So there are several features available in Java and C++, but they are not available in Go, right? In the next slide, we will see how we can achieve all these features in Go. In Go, we have simple struct and interfaces and packages. Very easily, we can use these features to achieve the object-oriented programming. Inheritance is achieved via composition and a struct embedding, encapsulation via packages, and polymorphism, we can achieve polymorphism via interfaces. Okay, so these are the things. So now let's dive into VS Code and we will try to understand inheritance. Okay, let's try to visualize a very simple software. Maybe we are developing a software for a product store, and inside our store, we interact with several people. Some people are our customer, some are our employees. Inside our employees, some people are somebody is working as a salesperson, somebody is working as a store manager, and somebody is working as an accountant. So let's try to visualize it, and we will try to design this application in a very better way. So for example, say we have one customer, let's call it customer. Then we have let's say call a salesperson, and we have a manager, let's call it manager, and an accountant. Okay, so here all the person we are dealing with, they are having few things common. Let's say every customer will have a name, and let's say an age, and say same like the salesperson also, they will have a name and an age, and the manager also will have a name and an age, and the accountant also will have a name and an age. By looking at all these three, we come to this conclusion that this name and age are very common to across all the people we are interacting with. Also, the salesperson will have also access to some other things. Let's say like the store, actual store wherever all the items are being kept, and the manager will also have access to the, let's say that he is having access level to all, and the accountant is having access level, let's say, to only the let's say like banks. So nobody else needs to access the banking related information within our store. So by looking at this design, so looks like these items, they are common to all the people we are interacting. So what if we can take out this item, this name and age, from these structs, and keep it somewhere else, and just derive those data, this information within these classes. So if we were working in the C++ or Java, so very simply we could have created a parent class. But in Go, so that is not possible. Classes is not there. So what we can do is ideally, so what if we can create a, let's say, a common class and call it a person, let's say person, and the person will have a name and an age, and just embed this person struct inside the customer, inside the salesperson, inside the manager, and inside the accountant, and just keep out these fields, this name and age, they no longer required. And here we can focus very simply on the specific whatever the actual attribute that are specific to this one. So by going this way, by using this way, this is called struct embedding. So by using the struct embedding behavior feature, so we can, whenever we embed the person struct into the customer, so this name and age, they will directly come as if as if it was declared inside the customer itself. Okay, and likewise. So so we can achieve inheritance. Okay, so let's try to do in the actual coding. Let's see that. I launch VS Code, and by the way, so let's also clean this. Okay, launch VS Code. Okay, VS Code open. I'll also create a project, go mod init, and let's say call it op. So I'll create a new file, main.go, package main, func main, and we will create as discussed earlier. So first let us try to write the whatever struct we are going to need. So we will have type person struct. Also, we will need type salesperson struct, and we will have manager. Okay, so the person we will define the actual field would be, so it would be a string, and the age would be, let's say, I32, I8 would be fine enough. And inside the salesperson, we will very simply embed person. Okay, so here what we are doing is that whatever the fields that this name and age, they will directly come inside the inside that they will available inside the salesperson. Also, I think we can also have another struct, let's say call, because broadly we are having two types of people. We are interacting with the customer and we are dealing with our employees. So let's say also create a struct for employee, and there we can embed there we can have some feature there common to within our all the employees. So here also we will embed the person, and every employee will have let's say employee ID, that is going to be, let's say, I32. And right now, so since we have already embedded the person struct inside the employee, so there is no point of salesperson having the person. Rather, very simply we can say employee. And next, let's say salesperson is having some other attributes. Let's say a monthly target. Capitalize it. That is, let's say that is a int. And inside the manager, so let's also embed this employee. This manager is also an employee of within our store. And also, so this manager is going to have certain other attribute that is specific only to the manager. So let's say access level. So by what I feel is that this manager can roam across the all the places within our store. So that's why so we will have access level. It is string. I think now this is good for our understanding purpose. Also, I think like there is a typo, or let's say call it very simply employee ID. Okay, so now let's try to create the actual objects. So let's say for the person, we can very simply create an actual instance of this person by simply calling it name. So let's say Neeraj, and age is, let's say, 32. So this way we have created a person, a struct, the actual object of person. Let's also create a let's say e employee of employee, and here we will here there are actually two ways. Go this way. Also we can, let's say 1 2 3 4, and also we can go another way. I'll duplicate this out and we'll rename it to, let's say, E1. So we can write this thing as this one as well, person. This is a person, and here I am going to create name, let's say Neeraj, and age 32. This is totally purely valid. We can create an object just right away without creating another variable. Okay, so let's call it e now. Also try to run this program and see what output we are getting. So let's say call it fmt.println, and here we will pass on e, and now we will try to run this program. So I'll say go run main.go. So here we are getting Neeraj 32, and the employee ID, actually the fields are this name. This name is coming from the person, name and age, and this employee ID 1234, that is coming from the employee struct as an employee ID. We can also access it individually as well. Let's say e dot name, e dot age, e dot employee ID. Okay, so if we run this program again, so we will get this data correctly. Now let's try to create a salesperson. So since we have already created employee variables, so let's say we will create a salesperson. Employee would be E. Salesperson will need to have a monthly target. And let's say call it this person needs to the monthly target is to sell, let's say 100 quantities. Also I'll duplicate this, and very simply now we will try to access the salesperson. I think like that would be better if we can have a write it something like this. So if we run this program again, so we will have the salesperson, and by the way this is the employee, and also we can create another one for a manager as well. So let's call it manager, and manager is having the access label as a string. So let's say call it, we will have all. Okay, we will also try to run this program as well, manager, and let's try to run this program. So here we are getting the salesperson as well and the manager as well. So this way, using struct embedding, we can achieve inheritance, and we can not only derive the properties, attributes, rather we can derive the methods as well. So let's say we can have a function, and that function is a struct function basically, and let's say call it display person, and very simply we will have fmt.println, and let's say person detail, and very simply we will say p dot name and p dot age. There is a typo. Okay, so display person. So I can call this display person upon whatever struct that has this person embedded. Okay, moving on. Let's try to call this display person function. So let's say we are going to call this display person function on the variable m, and display person. And if we try to run this program again, so we are getting this thing, person detail. So this was defined inside our display person function as a struct function of the person. But yes, we are able to access the any member function that was derived inside the our parent struct very easily from the child struct. Here actually, so just try to visualize it. This person struct is acting as a base class or a parent struct, and this employee struct is a child class deriving from the person struct. Salesperson is also derived from the employee struct, and the manager struct also derived from this employee struct. So whatever the attributes and the functions that was attached to that super not class actually super struct, so that would be available inside the derived struct as well. So that way we were very easily we were able to access the display person function defined inside the person struct from a variable of the manager. That's all for now. Hope you enjoyed the session. In the next session, we will implement encapsulation and polymorphism. I'll see you next. Till then, take care and happy coding.